Hello, everyone, and welcome to this webinar. I'm going to start with an introduction of ENENSYS technologies. As you may know, ENENSYS' goal is to efficiently deliver primarily video, but also any kind of multimedia content across all networks, satellite, terrestrial, cable, fiber, in addition to mobile networks, 4G and 5G. We optimize your network by providing tools and solutions which allow you to maximize your capacity and performance. We secure your network by providing solutions which are capable of delivering service continuity and monitoring tools enable you to react as quickly as possible when issues arise. We monetize through our targeted advertising and content regionalization solutions in the digital TV world. So today we'll focus our presentation on the benefits and the solutions around Multicast ABR, as explained before. And let me just start by some words concerning what the video streaming today looks like. Traditionally, when you deliver streaming content in your network today, you do it using Unicast. If you want to deliver, for example, a live sport content, and at the same time other VOD content, your subscriber will use the same CDN. They reach each new customer will consume a new set of resources in the network. So if you have two customers connected to your CDN, they will need twice as many resources as if you had only one subscriber. If you have 500,000 subscribers connected to your network, you will need 500,000 as many resources as only one subscriber. This is what I'm trying to illustrate in the animation, where many different houses are connecting to live or VOD content. So now, concerning another topic, it's the popular events and the prime time, or what we usually call the content storms. Let's say you are an operator and you want to deliver two games of the soccer, the European Soccer Champions League, which is a very popular soccer championship in Europe. You will have to be able to make available CDN resources in your network to deal with the peaks of users, whatever the popularity of your event. So your CDN network needs to deliver the appropriate quality to all your subscribers, independently of the traffic or risk your customers might have a problem with this situation if you are not capable of delivering it as promised. So this will end up probably in very bad quality of experience for them if your CDN is not properly dimensioned. And if you want to dimension your CDN properly, then you have to add and add caches as your number of users grow. So as you can see in this graph, where there is an example of the growing number of CDN caches with respect to the number of users consuming the content. So another important topic when it comes to streaming video is the quality that you deliver. It's now proven by several studies that low quality is not good for the business of content delivery. This one is a study from Akamai that says that you could be losing up to 3/4 of your users, of your customers, if you don't provide appropriate quality, if you have repeated quality issues. So this is very important to take into consideration if you want to avoid churn. So, okay, now we have set, let's say, the context of the problems that you can face when you deliver content over using ABR or OTT technologies. Now, let's take a brief look at what the Multicast ABR standards and use cases look like. First of all, for those not already familiar, just wanted to say that, okay, Multicast ABR works as follows. Let's say that you have, again, the same live content, sport content that you want to deliver to all your customers. In this case, if you are using Multicast ABR, you're going to add in your network a node that we call the Multicast ABR server that is going to come in parallel of your CDN to deliver the content in multicast. So, and you have to integrate in the customer premises an element of the system that is called the multicast gateway or multicast agent. So now what happens if you want to deliver the live content to your users? In this case, using Multicast ABR, you're going to be able to liberate bandwidth and deliver content in a more efficient manner, because you're going to be using only one resource of the network to deliver many users at the same time. You still continue to use your Unicast resources as in the previous example, for example, to deliver VOD, but now you have more bandwidth to deliver, first of all, the live content, because you're going to deliver one using one resource for the equivalent of the resources to deliver one user, to deliver thousands. And now you have more room to deliver your Unicast services as well, like VOD. Now, so what is this all about, and what are let's say, the resources you have to implement Multicast ABR? In order to help you to deploy Multicast ABR in a more flexible manner, DVB has taken the responsibility of writing a standard that was issued at the beginning of this year. And basically, this gives the possibility to the operators to deploy this technology with more flexibility and confidence. Okay, the standard defines, first of all, a global architecture and the interfaces. Okay, on the diagram that we are seeing, you can see on the left side the traditional content and head-end with origin packagers introducing and producing the ABR streams. And on the right side, you can see the users of the content connected to a broadband network with the traditional CDN that, of course, plays still a starring role in the delivery of the content. And then DVB mABR defines a multicast ABR server that is here to encapsulate the content ingested from the origin into multicast protocols to deliver it to the users. And you have a multicast controller that is responsible for configuring the services that we can find here, and the multicast gateway, which is the entity in the home premises. Well, not necessarily in the home premises, but let's say it's the entity at the other end of the network that is going to convert the multicast traffic into unicast to deliver the end users, players to to play their contents. There is a last element here that is called the multicast rendezvous service, which is used to keep, let's say, a record of multicast gateways, status, and current multicast session. This rendezvous service receives the first request, for instance, from the player, and is responsible for determining whether there is a multicast session available for the service being requested, and if there is a multicast gateway available, to deliver it to the service, to the user. Other important topics defined by the standard are the sessions management, okay, which allows to guarantee the database consistency between multicast servers and multicast gateways. You have, of course, the interface between the controller and the multicast server, which is a REST API to configure the services in the multicast server. You have the multicast gateway configuration as well, which is defined in terms of the APIs that could be either through a REST API, can be done in-band by using the communication in-band of the broadband network, or just in time, which is basically a configuration that is going to be sent by the multicast rendezvous service whenever the multicast gateway requests a new content to play. The standard, of course, defines the system operation, start, stop sessions, ingesting, playout modes, how to repair in case of an error, and how to do unicast assistance in a situation where the multicast is not available or disappears at some point. And last but not least, the DVB mABR standard defines the protocols used to transport the multicast streams. And these protocols are in number of two. There is the 3GPP flute and the ATSC 3.0 route protocol. Now, let's take a look at what the use cases, different functions that we can get from the Multicast ABR. Let's say, do you remember the content storm headache that I talked about before? Well, as previously stated, it can generate video quality degradation and high cost due to CDN resources required to manage the peaks. Using mABR, Multicast ABR, you can detect those peaks. You can detect them, detect the consumption, and organize your network to trigger the multicast whenever necessary in order to avoid and eliminate those content storms. You eliminate the quality problems and avoid the bottlenecks induced. This translates into a much better network scalability, and I even would say even better margins in the exploitation of your network because you reduce cost. So another important topic is delivering DTT-like quality experience. Let's say that you want to deliver sports, for instance, where you don't want your users, your subscribers, to be spoiled because they receive the content, the score, the goal was watched too late with respect to the traditional DTT television. So what's going on today in unicast networks is that you have the traditional origin encoding and origin CDN networks and the video player with the user here. The unicast network is jittery by nature. You can have unpredictable peaks of traffic and congestion that could make the delivery time unpredictable. This is why traditional players, they require buffering in order to cope with the uncertainty of the segment's arrival time. So to avoid underrun, to avoid lack of segments at any given time, the players, they use buffers that go around 3 or 4 segments, let's say. So the delivery of those segments can be a little bit late, so there will always be a segment to consume and avoid problems in the playing of the video. This, of course, introduces latencies, okay? These latencies, let's say you have segments of 4 seconds. This is 4 or 5 seconds is a traditional configuration. This could introduce latencies theoretically here of about, more than 20 seconds of latency, and sometimes it's much more, depending on the network and depending on the configuration of the CDN. And then, as I said before, your customer can get spoiled for this reason. Now, let's imagine a network where you introduce Multicast ABR. With Multicast ABR, you have the same architecture, except that you introduce the multicast server here just right after the packager, and a multicast gateway or a multicast agent sitting on the customer side. I put the names here of the ENENSYS solution, MediaCast, Broadband, and Cube Agent, but these are multicast server and multicast gateway. So in this case, the multicast transmission is done I would say in guaranteed bit rate, okay, which guarantees, in fact, the fact that the transmission over the network is done in a more, let's say, smooth way. The network traffic is smoothed, and this is going to result into a much more predictable segment delivery time, which is in turns largely reduce the need for buffers. Okay, and in this case, we have made testing in which we can reduce the buffering to 1 or 2 segments, and the fact that you are using multicast delivery, it increases the possibility, it enhances the possibility to deliver content using low latency, because you are pushing the content to the users. And if we imagine that we can reduce using low latency the segments or chunk size to, let's say, something about 250 milliseconds, sub-second chunk size, we can reach latencies of about, less than 5 seconds, which is very close or even equal to what we can do in DTT today. Now I'm gonna just show you some use cases of deployment use cases of Multicast ABR that we can imagine in different networks. We have in the case of the distribution to homes, you can, as I said before, okay, imagine a delivery over a broadband network, ADSL, cable, fiber, to home customers, where the MediaCast broadband is deployed just beside the origin packager. You go through the broadband network and you deliver to the Cube agent or Multicast ABR agent in homes. This is one possibility. Another possibility is for satellite operators or satellite service providers. We can as well use the ENENSYS solution, MediaCast broadband satellite modulators, to deliver content over satellite and reach users anywhere. This is very trendy right now. There are a lot of requests regarding this use case because satellite operators are very interested in going OTT today. We can imagine use cases to do contribution to the edge. In some regions, in some geographies, some parts of the world, it is not possible or it's difficult to deliver content using the existing infrastructure, terrestrial infrastructure. So in this case, we can reach POPs, points of presence of telecom operators using satellite and multicast ABR in order to feed those POPs instead of using the terrestrial infrastructure. And of course, there is a possibility to deliver in multicast using an existing IP network if the IP network is can be used and exist. I wanted to provide here as well a last use case of deployment, because it's getting some traction as well in the market. Is, as you may know, today 5G everybody's talking about, but 5G is going up, even if there is still some 4G. 5G is driving a lot of applications that are very bandwidth hungry. And the thing that we propose is that today, the radio, 5G radio, is of course very performant and can absorb this bandwidth hungry applications bit rates. But then you need to think about your network behind, the CDN. You're going to be facing the same problems I exposed before, meaning the CDN will have to grow very quickly, scale very quickly, and you will have to spend as well money to make it grow. Here, what we propose is to do some kind of multicast to the edge and deliver very close to the radio network the content. So you can deliver scalability and quality of experience to your customers, to your subscribers. And another important thing with ENENSYS solution is that our solution is capable of going broadband and mobile. With the same solution, you can address your customers that are using your 5G network, and when there is a handover, we can, with the same solution, deliver the content to the 4G using LTE broadcast. So that concludes my part. I will handle now the talking to Bartolo, who will continue presenting the OTT at scale solution.
Yeah, thank you, Williams. So now let's take a look at how the ENENSYS can help you to deploy this technology, Multicast ABR, on your network. So the OTT at scale architecture is something we were thinking for any kind of network. So we have the possibility to actually deploy the Multicast ABR solution on your broadband network if you are a broadband operators, by introducing the MediaCast controller, MediaCast broadband server that can deliver the multicast streams over the broadband network, and the Cube agent that is installed on the home gateway or the end user devices. We can, as already mentioned by Williams before, deliver the content over multicast using a satellite link, so do the traditional TV over satellite, but using Multicast ABR solution instead of the traditional MPEG-TS system. We can also deliver the Multicast ABR on top of the digital terrestrial TV, so DTT connection, also always putting an agent in the set-top boxes at home, and the possibility to encapsulate IP over the terrestrial signal. And of course, since we came from the world as well for mobile devices, we can integrate the MediaCast mobile that is delivering the content over a 4G or 5G network, so you can reach directly the mobile devices and your end user that are more and more watching content over mobile devices. And as ENENSYS is also providing monitoring solution, we can introduce in this OTT schema the different point of monitoring using all our probe system that is provided by our test3 brand, that is capable to monitor all the pieces, all point of the chain, so that you can ensure the quality on and verify the consistency of the distribution network. What are the main features that we propose in our solution? First of all, we are focused to deploy you a solution that is standard. So we are following the DVB standardization to implement what has been defined last March by DVB in the first phases, and we are leading the second phase for the new requirement, in particular for target advertisement and other features that we will see later. And this is our main objective: provide something that is standard, so that you don't have stack with our solution. You can also build the solution with our server and client agent provided by a third party or already integrated in your own gateway that follow the standard DVP. Second point, we provide a solution that can help you to select which content should be multicasted in your network based on the consumption of the content. So we have this capability to have a dynamic management of the switch within the Unicast and the Multicast distribution based on the popularity of the content. That can be calculated by the own statistic that we can get from our Cube agent, but we can also integrate other statistics that came from your existing deployment of the OTT services. We already implement ultra low latency chunk encoding, so the system is compliant with the existing CMAF and chunk encoding system that enable OTT content to be delivered with lower latency, and we introduce this capability as well in Multicast so that we can even go further and reduce then more the latency, or for your live content, live sport that are very crucial, and you need to have a quality of experience that is similar to what you already have on the traditional channel for DTT and so on. And last but not least is the capability to introduce photo error correction. This is very strength of our products, that we can introduce this capability to actually correct packet loss on the network by having photo error correction. This allows as well to reduce the latency, because we don't need to have a repair system in place to recover and to have some back and forward from the network to repair the small errors. That can be achieved just by our very powerful photo error correction that has been tested and deployed in the last 10 years in millions of devices. How we can integrate the solution in your ecosystems. So we have deployed and developed two different architectures. The one that we call distribution to home is the possibility to actually multicast the content from your headend down to the on-premises of your customers. So the multicast streams is going from the headend of the network down to the on-premises and received by the home gateway or other devices inside the home network of your subscriber. But we also have developed the contribution to the edge, means that the multicast streams now is not going down to the end user premises, but is reaching the edge of your network and go to pre-caching content in your CDN edge environment. So in this case, the link would be a satellite link or whatever, so that we can do mobile edge computing as well for 4G and 5G networks, where we can pre-cache content near to the users. The Cube agent, as we mentioned before, Multicast ABR requests an agent on the close to the end user device, or do translate back the Multicast streams to the Unicast word, so that you don't have any change in the application side. So you can keep the application as they are today, watching content over OTT, but have a Cube agent, so the agent that is translating back the multicast on Unicast, and we can deploy it in any devices in the on-premises. Of course, the home gateway is the first entry point of the house, so it's a normal strategy to deploy in the home gateway, but in some cases it's not possible, either because the home gateway is not powerful enough, or for other constraints on the home gateway itself. The agent can be deployed on the set-top boxes, so that you can receive the multicast on the set-top box and go back to the Unicast from the set-top box point of view. In this case, you have a better capacity, because set-top boxes are usually more powerful, have more storage capability, so you can also pre-cache some VOD content, so that you allow, with a very low bitrate network, to actually store or pre-store some VOD content with 4K or 8K quality, so that's something that is not possible on live, and it will be difficult to do with the traditional network if you have a very reduced bit rate to the end user. So how it works, the Multicast ABR, we have two possibilities. The first one is by introducing a rendezvous server that actually is working this way. So we have the Multicast controller that is doing the first step, so it's configuring the network, it's providing the configuration of the Multicast delivery for the content. The second step is that this configuration is provisioned to the Multicast rendezvous service and as well to the Multicast agent that is in the home gateway. The third step is for the Multicast server to start ingesting the content from your origin packager and start the multicasting when there is enough user to multicast it. So the player in the home devices is requesting the playback of the content to traditional rendezvous service. The rendezvous service is detecting there is a multicast agent in the home premises, so it redirects the player instead of the traditional CDN. It redirects the player to the multicast gateway, so that from now on the player always interacts with the multicast gateway, and the multicast is joined by the multicast gateway. So and the multicast gateway can still repair or start to have a fast start of the playback by using the CDN, traditional CDN network. So you don't need to deploy any additional Unicast server to do the repair, as it could be done by other solutions. This solution can be relying only on your actual CDN deployment. Another way to implement it is by actually make the application aware of the multicast capability of your network. So the same thing happened as before. There is a provisioning of the configuration for the multicast streams. There is the injection from the multicast server. And now the application is aware that there is the capability to have a multicast agent. So it discovers the multicast gateway in home premises, and from the discovery, it starts to request the content directly to the multicast gateway. So it doesn't go anymore to the rendezvous service, but it goes to the multicast gateway. And the multicast gateway is taking care to join the multicast delivery and start and providing the media segment to your players. So in this case, there is a little bit of integration in the player itself, or the application of the player really. But there is no need to deploy the multicast rendezvous service. Hope this is enough clear. I let the floor to Williams again. They will introduce you the conclusion of this webinar and a demonstration of our products. Williams?
Yes, thank you, Bartolo. Yeah, let's just summarize somehow what we have been talking about here. The objective of the ENENSYS solution, of course, is to improve your CDN and to generate new revenue with a future-proof solution. This is the message that we would like to pass. So let's face it. Churn is one of the main problems that an operator could face with the competition. So the objective, one of the objectives and benefits of our solution is that we allow operators to create guaranteed live TV streaming offers with a very good quality of experience. Secondly, we want to guarantee that your network is future-proof. Tomorrow, if you want to switch to a new multicast gateway from a competition or want to introduce new features, you can do it in an easy way because of what Bartolo explained. We are DVB and 3GPP compliant. It's open interfaces, fully standardized. There is no proprietary lock-ins. We are open to work with any CDN, with any a multicast gateway, or our multicast gateway can interwork with any, of course, standardized server. We propose you to better use your network resources. This is good for your money, but it is good as well for the planet. We dynamically detect the popularity, and we reduce right away the consumption of bandwidth in your CDN using multicast technology to the most popular channels. So, and of course, I keep saying that, but we help you to increase revenue and extend your reach by providing and extending your services potentially to mobile networks, but not only mobile networks. We could talk about satellite and the fact that you can do 5G and 4G as well. So that is the summary of the benefits. Now, are we going to open for some questions, Etienne, Sandrine, before going to the presentation of the video with the demo?
Yes, of course. Yes, we received some questions. We thank you very much for that. So first question is, where should need to install multicast gateway for OTT platform users?
Sorry, you said where?
Where should need to install multicast gateway for OTT platform users?
Well, maybe I can start answering, and Bartolo can complete. If I understand well the question, my answer would be that the multicast gateway at home, in a home network, can be installed either in the home gateway or router, home router. So you can reach, as explained before by Bartolo, all the devices at home, TV set, smartphones, tablets. Or we can imagine, if you don't have enough room in your home gateway, to install install it in the set-top box. Meaning that you are gonna typically, as for today, it's usually said that the TV set is the biggest consumer of content. So we could imagine to install the multicast gateway in the set-top box as well. Bartolo, do you have any additional?
Yeah, and some operator also asking if we can deploy it on the end user devices. Of course we can, but in this case we need to have a very good network for Wi-Fi, or because usually the devices at home are connected through Wi-Fi, your broadband network. So either you enable Wi-Fi multicast on your home gateway, or we have a solution that can actually encapsulate on Unicast and connect all the devices to the home gateway using a Unicast protocol, so that we can encapsulate the multicast from the home gateway to the devices. So there is this third option that is also feasible. But the first two are the preferred one.
Second question is, how do you deploy your agent on CPE in the field? Specifically, how do you get permission to do so?
Bartolo, you want to answer this one?
Yeah, so basically the agent either can be fully integrated in the firmware of the CPE, so that it can be, we can work with your CPE vendor and integrate our agent in the CPE. Afterwards, if it is an Android system, it can be deployed as an application and running as a service in Android set-top boxes. So there is different way to deploy it. Our agent has been deployed on millions of devices, set-top boxes, gateways, so it is quite compatible with all the architecture that you can have at in your network. So
yeah,
please send us some details of your network. We can maybe answer more in detail about what we can do.
Okay.
Thank you for the answers. We have other questions, but as we want to be on time, we will answer your questions just afterwards. Thank you.
Okay, thank you, Sandrina. Okay, so we have a video that shows a demo that we have installed here in our headquarters. Let me go. I hope normally. Okay, so basically, this is the architecture of the demo. On the left side, you will have the head end with our Mediacast broadband that we already presented to you. And on the right side, you will have two different homes. One is Dave's home, and the other one is Vanessa's home, with Cube agents in the home gateways. This is the setup. The setup installed, as I said before, in our headquarters. Here I'm pointing to where the origin and encoder and origin are running in this PC. Then